So 5, 6, 7, and 8 says name the sides of each angle. We'll just do one. So number 5 is angle 6. What are the sides of this angle? NO and NM, right? It's just the two rays that create the angle. So if y'all see that in your homework, we essentially already did that in the previous problems. Just know how to name the sides. We name the sides with 2 letters. We name the whole angle with 3. Easy enough there? All right. I want to get to the more complicated stuff. And then we already practiced this. Write another name for each angle. That's exactly what we did up here in the Galaxy pen. All these different angle M, angle 5, angle NMO, angle OMN. Those are the options on how to name an angle. Okay. All right. Let's go down here. Classify each angle as right, acute, or obtuse. It says use a protractor to the nearest degree. For now, let's just use the picture that it gives us, okay? Angle UZW. So I'm looking at number 11. Angle UZW. Let's just do this together on the screen. You guys don't need to copy this down in your notes. Angle UZW. What do you guys see there? Y'all see a right angle. So somebody go ahead and describe to me why you see a right angle there. Yeah, what's this little thing here? The square is telling us it's a right angle. Okay, here's kind of again, another part of this, reading these diagrams. Here's what we see in our minds when we think of a right angle. Not that. That. Okay, the orientation of that angle is going up and down, right? Well, what happens when that angle is no longer just going straight up and straight out to the right, or straight up and straight out to the left, right? Can this still be 90 degrees even though it's turned on its side? Absolutely, right? All we're looking at from this picture to this picture is the box inside the vertex. The box inside the vertex, right? So just because this angle in highlighter, UZW, is tilted onto its side just a little bit, right? We would prefer visually for that angle to look like this, right? Oh, that's not good. Like this. Straight up and straight out to the side. But it's just rotated on the vertex to the right a little bit. All we're looking for to determine if it's a right angle, again, is that box inside of the angle. So we would say UZW is a right angle. Okay, now great example here. Instead of UZW, number 14 asks us for UZT. UZT. So instead of going UZW, we'll start at U, go to Z, and come out back to T. I'm going to erase my box. Okay, what kind of angle is that? Acute. It's less than 90. We don't need a protractor to see that, right? This angle here is smaller than the blue angle here, right? Visually, we can see that. Okay, and then I'm just going to ask you guys one. If UZW is a right angle, okay, how would we classify angle UZX? Obtuse. The difference from W to X opens that angle up and increases the degrees. Okay, is there any way for us to tell the measure of angle UZX if we're just looking at it on the TV screen right here? All we know is that it's greater than what? Greater than 90, okay? And again, we'll use protractors on another day, and I'll teach y'all how to use the protractor. We can measure that angle if we physically have a protractor in our hand and put it over that angle. But here, I just want you guys to know there's no guessing like, oh, it looks like it's greater than 90, so maybe it's 110. If the problem doesn't give it to you, there's no way to tell. You just know it's equal to 90 from the box. It's less than or greater than 90, which makes it obtuse or acute. Okay? Any questions on classifying those three types of angles? Okay, and let's get to the meat and potatoes of it. We're going to do problem 15 together, and then I'm going to give you your homework. Okay? Okay, it says in the figure, line CB and CD are opposite rays. That should have been a vocab term for y'all as well, right? Look back in your notes. What's the definition for opposite rays? Okay, Miles, what were you going to say? Yeah, exactly. So opposite rays are two rays that share an endpoint, right? Two rays that share an endpoint. So CD and CB are opposite rays. CE bisects angle DCF. Okay, so we're getting a lot of information here. CE bisects angle DCF. Y'all should have had bisect in your vocab notes as well. What does that mean? Cut in half. Cut in half. Did y'all have that in your vocab? Angle bisector or bisect? Right? Cut in half. So CE cuts DCF in half. So what do we know? I'm going to go ahead and kind of jump to a conclusion here. What do we know about DCE and FCE? Great word, Willow. They're congruent. They're congruent. So just like a segment bisector cuts a segment in half, an angle bisector cuts an angle into two equal parts, two congruent parts. So go ahead and write this down. I'm going to have y'all draw this here in a second, but just write this down. Angle DCE is congruent to angle FCE. And then we could make the statement that angle DCE plus angle FCE, the two parts of the bigger highlighted angle, equal the whole thing, the whole bigger angle, which is angle DCF. Write that down in your notes, and then I'll have you copy the diagram here in a minute. Okay, and then same thing on the bottom side of this drawing. It says CG bisects angle FCB. And I'm not going to make y'all write this down again, but just for the visual here, CG, I'll do it in this, CG bisects, make sure I read this right, angle FCB. So now I'm looking at FCG and BCG being congruent to each other as well. Does that make sense to you guys? The idea of bisecting? So now we use that information to put some variables into the problem and do some algebra here. Okay, so we're going to do number 15. So if the measure of DCE equals 4x plus 15 and ECF equals 6x minus 5, then find the missing angle, DCE. For the sake of time, guys, let's do it together here real quick on the board, and I can have y'all draw it on your notes here in a second. So we're going to label this picture. Angle DCE equals 4x plus 15. So inside this angle, I'm going to draw this little curvy line that's representing the measure of the angle. Okay, it equals 4x plus 15. And then the other information it gives us is angle ECF equals 6x minus 5. And it asks us for the measure of angle DCE. Okay, so what did we just say we know about these two angles? This is what it's asking us for. They're congruent. So what does that mean? Yeah, their measures are equal. So we just set up, go ahead and do this on your notes, set up this algebra problem here. 4x plus 15 equals 6x minus 5. And again, more than half of the problem is just setting it up correctly. Once you read the figure, right, you read the diagram, you set everything up the right way, and you get to this point, right? I hope that we're at a point now where we've kind of done our algebra review. This is the easy part, right? Solving for x. This is the easy part. We've got to be able to understand what the problem is telling us and get to this point, setting it up correctly. Okay, so I'm going to subtract 4x from both sides, and I'm going to add 5 to both sides. And we'll get 20 equals 2x, and x equals, divide by 2, 10. Okay, now we got to ask ourselves, is that what the problem asked us for? What did it say? Find the measure of angle what? DCE. So now how am I going to take what I know and find that? I'm going to take my x, right, and I'm going to plug it back in all the way over here to angle DCE. And we can do that really quick. X equals 10. 4 times 10 is 40. Plus 15 is 55, right? So we get 4 times 10 plus 15. So the measure of angle DCE equals 55 what? Degrees. Bam. Okay, y'all are going to see quite a few problems just like this one on your homework tonight, okay? What else do I know about angle FCE? It's also what? 55. Yeah, so angle FCE is congruent to angle DCE, so it's also 55 degrees, which means I know what about angle DCF, the whole thing? It's 55 plus 55, so it's 110 degrees. So again, taking the picture, being able to set the problem up correctly and get the information out of it that you need is hugely important. The algebra should be the relatively easy part of these questions. All good. We're running right up to the bell today. Okay.